Going on, guys, in this video we are going to see an example or an application of first order differential equation in mixing concentrations. Here we have this question asking a large tank holds 200 gallons of brine solution with 40 pounds of salt. A concentration of 2 pounds per gallon is pumped in at a rate of 4 gallons per minute. The concentration leaving the tank, so this would be tank right here, okay, tank is pumped out at a rate of 4 gallons per minute. The first question asking how much salt is in the tank after 1 hour, and then the second question is asking how much salt is in the tank after a very long time. Now in order to figure these things out, we have to create a standard function model of this equation. So here we have this equation for this one, that is dA by dt is equal to R1 minus R2. dA by dt represents rate at which A of t is entering in the tank, and R1 is representing rate at which A of t is entering the tank. So this is changing in the tank. dA by dt, rate at which A of t is changing in the tank. R1 is entering the tank, R2 is leaving the tank, right? Now we have to figure out this R1 and R2. That's the main thing. And here if you look at this one, they have given that a concentration of 2 pounds per gallon is pumped in. So this is entering in, right? This is the concentration entering in, and the rate of this one. And we need the R1 in terms of rate at which entering the tank. So we have to give the rate in terms of pounds per minute. Now to change this one into pounds per minute, we just try to multiply. If you look at the unit, that makes sense. Let's arrange this in an equation like R1 is equal to 2 pounds per gallons. I arrange the unit like denominator here, so you will see clearly, right? 2 pounds per gallons times 4 gallons per minutes. Now you can see this gallon and gallon cancels each other. Finally we will end up with pounds per minute. So that's going to give us 8 pounds per minute, and this is our R1. Now let's look at R2. R2, we need to have the rate at which it's leaving the tank, and here they have given the rate in gallons per minute. We have to find it in pounds per minute, but we don't have the concentration provided. But if you look at this one right here, we have 200 gallons in total and 40 pounds of salt is there, but we cannot use this one because this is changing, right? So we cannot use this one. So what we are going to do is we are going to pick up a general term, for example A is unknown, and divide this one by 200 gallons, and then we are going to multiply this one by the exiting rate, that is 4 gallons per minute. So this is going to be A over 200, and this is going to be pounds per gallons multiplied by 4 gallons per minute, and that's going to give us, and here again you can see that gallons and gallons cancel each other, and finally we will end up with A times 4, that's going to be 4A divided by 200. 4 divided by 200, if you divide 200 by 4, that's going to be 50. So this is going to be A over 50 pounds per minute. So this is our R2 value. Now let's go ahead and plug it in this equation. dA by dt is equal to R1, that is 8 pounds per minute. So this is going to be 8 minus R2, that is A over 50. And from this one you can already recognize this is the pattern for first order linear differential equation. And when we have first order linear differential equation, that the standard form should look like this. dA by dt, if you move this one to the other side, that's going to become plus. So this is going to be plus 1 over 50 times A is equal to 8. So this is a standard form of first order linear differential equation. Now you know that when we have first order linear differential equation, what we do is we pick up the P of t value. P of t value is basically the value that multiplies this A value. So this is the P of t value right here. P of t is 1 over 50, and then we have to find out the integrating factor. to find the integrating factor, we use this equation that mu of t is equal to e power integration of p of t dt. So this is the equation we are going to use to find out the integrating factor. Now let's go ahead and plug these values. So this is going to be mu of t is going to give us e power integration of this one, so 1 over integration of 1 over 50 dt. Since 1 over 50 is a constant, it's not going to change. If you integrate dt, that's going to become t. So the integration factor is going to be e power t over 50. Now after we find out the integrating factor, what we have to do is we have to multiply this equation both sides by the integrating factor. So we have to multiply this side by integrating factor, that's going to be e power t over 50, and in the other side also we have to do the same thing. We have to multiply this one by the integrating factor, so this is going to be e power t over 50, and after we multiply we have to do the integration both sides, and here we do the integration right here, also we do the integration right here respect to t, so this is going to be dt, and let's continue this one right here. Okay, and then the best thing in linear first order differential equation is when you do the first part, the first side of this equation. Let's do the multiplication first. Okay, so we are going to have integration d over dt. I take this one outside, I keep this a inside, a times e power t over 50. The best thing is if you find the derivative of this part, that's going to give this one back, right? That's why we find this integrating factor. When you multiply, you will get this pattern. Like when you find the derivative of this one, you will get this one back. So this means this is equal to this one. If this is equal to this one, this must be equal to this one, right? So that's what we are going to do right here. We are going to equate this one to other side, and this is the respect to t. We are integrating this one respect to t. And in the other side of the equation, we are going to have integration of this one, and the integration of 8 is a constant, so it's not going to change, and e power t over 50. So when you integrate this one, we have to divide this one by the value, actually whatever the constant we are multiplying this one by. This is 1 over 50, we are multiplying the t by 1 over 50, so we have to divide this one by 1 over 50. Dividing this one by 1 over 50 is same as multiplying this one by 50. So 8 times 50 times e power t over 50. So that's going to be the integration of this one. Also we have to put a constant right here. So let's say that is c1. Okay, now we have done this part, and integrating this one is, and we have derivative and integration, both will cancel each other, so we don't have to worry about integrating this one. This is going to be just a times e power t over 50, and in the other side we are going to have 8 times 50, that's going to be 400 e power t by 50 plus c1, and if you notice we have e power t over 50 both sides of this equation. Now to get rid of this one, what we can do is we can just divide everything by e power t over 50, and if you do that you will get a is equal to 400 plus c1 over e power 50 over 50, or you can just write it's c times e power negative t over 50, right? So both way it will work. Now we have brought this pattern, and that's it. Now this is going to be our equation, and also we know one condition. In the initial condition we had 40 pounds, so a of 0 is 40, right? 40 pounds. Now we can use this one to find out the c value. So here what I'm going to do is I'm going to combine this two c together and call it c. So we can let's get rid of this part. We need some space, so let's get rid of this part right here and continue this one right here. Okay, so we brought this final equation. Now let's write this one down here. So A is equal to 400 plus C1 e power minus t over 50. This is what we derived. Now C1 times, we can let this, since this is a constant, we can let this one to C1 e power negative t over 50 to C. So we can write this equation as A of t 400 plus C, right? And we know that the initial condition we had A of 0. A of 0 is equal to 40. So we can equate this equation to this one. So this is going to become 40 is equal to 400 plus C. From this one we can find the C value. C is going to be equal to negative 360. Now we can find out we can write our function model of this equation, and that's going to be A of t is equal to 400, and we found out the C value, that is negative 360. So this is going to be negative 360. I'm using this equation. Okay, now we can write negative 360 times e power negative t over 50. Okay, actually I made a mistake right here. If A of 0 is 40, this is C e power 0, right? E power 0 is 1, and that's when we can do like this, because if I take these two together and combine, that's going to become just 400 plus this one. That doesn't make sense, right? So that's a mistake. So this is going to be t. We know that t is equal to 0. A of 0 initial condition, t is equal to 0. So e of 0 is going to be 1, and from that one we found out for C value. We can keep it as C1, right? C1 value, that is negative 360, and we derive this generic function. Now from this one we can solve everything. Now let's go ahead and look at the first question. First question is asking how much salt in the tank. How much salt is in the tank after 1 hour? So 1 hour, since we are looking everything in terms of minute, if you look at the unit we had, it's minute. So this will work in terms of minute. So you have to convert this hour into minute, and if you convert this one into minute, that's going to be 60 minutes, right? A of 60 is going to be equivalent to 400 minus 360 e power negative 60 over 50, and if you calculate this value, you should get 291.60 pounds of salt. So that's how much salt is going to be left after 1 hour. Now let's look at the second question. How much salt is in the tank after a very long time? So when they say very long time, what we do is we take the limit of t approaches infinity, and we put our generic function over there. Okay, so limit t approaches infinity. Infinity is very long time, and then we bring this function 400 minus 360 e power negative t over 50, and from this one we can see that e power we are getting, if you plug this infinity for t value, that's going to be e power negative infinity. E power negative infinity is 0, so this whole value will become 0. Finally we will end up with 400 pounds of salt. And this one makes sense because if you look at the initial condition, we know that pump in rate and pump out rate is same, right? 4 gallons per minute, 4 gallons per minute, and initially we had 200 gallons, and the concentration in is 2 pounds per gallons. So this is going to be the concentration. So from this one we can see that 200 gallons multiplied by, so 200 gallons multiplied by 2 pounds per gallons, that's going to give us 400 gallons of salt. So from this one we can already verify this answer. This is correct. I hope this helps. Thanks for watching.